Okay, this video is about the mole ratio and converting from moles to moles of another substance. Okay. So the first thing you need to understand is something called the mole ratio. And the mole ratio is simply just showing a relationship between two different substances within a chemical equation. And so you have to have a balanced equation in order to have a mole ratio, in order to show this relationship. So first thing you need to do before you ever do a stoichiometry problem is make sure that you have a balanced equation. So right here we have mercury oxide decomposes to make mercury and oxygen. So we have one mercury on the left, we have one mercury on the right, so that's pretty balanced. We can move on to oxygen. Well, we only have one oxygen here, but we have two over here, which means we're going to need to multiply this guy by 2 so that there ends up being 2 oxygens right there. But that 2 also distributes to that mercury right there, and that becomes 2 mercuries there, which means we need to multiply by 2 right there to make it be 2 total mercuries. If you're struggling with balancing equations, go ahead and look at my last playlist about balancing equations, and you should be able to catch up there. So now that we have a balanced equation, we're going to be able to write a mole ratio between any of these three substances. So for example, we could say, well, for every 2 moles of mercury, we are also making 1 mole of oxygen, diatomic oxygen. We could also say for every 2 moles of mercury oxide, we can make 1 mole of oxygen. So literally what I'm doing is taking the number that's the coefficient from that specific substance. Okay, so it kind of sounds like a lot. It is a lot at first, but it really isn't that terrible, and I bet you'll do great. So let's try to do this example problem. So first thing we're always going to do is underline our given and circle what we want in a problem, because a lot of the times we'll give you guys questions that are kind of tricky the way that they are worded. So just be careful. Underline the number they give you, circle what you want to get to. So you're always going to start with a fraction, okay? It says it right here. It's going to be your given substance moles over 1. So we have 3.0 moles of mercury oxide over 1. And then we're going to multiply that by our mole ratio, because our mole ratio helps us to translate between substances. It's kind of like if you're bilingual and you have a parent who speaks one language, but they don't speak another one, and your friend's trying to talk to your parent, but they don't speak their language. You're kind of like that liaison between the two of them, and you translate between the two of them. The same thing here happens with your mole ratio. They can translate between mercury oxide and mercury, or mercury and oxygen. So the way you do a stoic problem, you take whatever unit and substance you have right there, and you're going to put it directly diagonal, like so. Okay, because what you're trying to do is cancel out that unit. Now, we're going to put whoever we want on the top, and that's going to be moles of mercury. And again, this is exactly what this formula is telling us up here. So it's saying, okay, given substance of moles over 1, and on the bottom, down there, we have moles of given substance from the balanced equation, and moles of wanted substance from the balanced equation, which is exactly what I have right here. So now all I have to do is find these 2 numbers that actually go with the units. And what we can do with our mole ratio is we can just go look at our balanced equation, because that tells us that ratio or that relationship we have between those substances. So the number that's in front of Hg, or mercury, is 2. So I'm just going to put a big 2 right there. And I'm going to go look at HgO, or mercury oxide, and I'm going to see that there's a 2 in front of that. So I'm just going to make that a 2. And when you have the same unit and substance on the top and on the bottom, you can cancel those guys out. So we're kind of making a diagonal pattern there. And you'll see that pattern as we get into more complicated problems. And so what you do in stoic, you just multiply across the top. So we're going to say 3.0 times 2 divided by that 1 times 2. So that becomes 6 divided by 2, which really equals 3 moles of mercury. Okay, so that's how you convert from moles of one substance, like mercury oxide, to moles of another, like mercury. And we're going to keep using that mole ratio and converting between moles of one substance to another as we do our stoichiometry problems and when we eventually get to 4 fraction problems.